Hello guys, um, it's me, Ubukome Jaife from Special Maths, and today we're having another problem solving session. Today we're looking at an algebra problem because last time we looked at the geometry, so today we'll look at an algebra problem from the UK. Yes, this year's British Mathematical Olympiad second round, problem 2. The problem was a functional equation, and you can see that on my screen. And the problem basically says that we should find all functions f from the positive integers to the positive integers, such that for all x and y, we have that 2y f of x squared plus x is equals to f of x plus 1 f of 2xy. Okay, so that's our problem. So we'll dive into that now. So we'll say let's the problem be p of xy, rather let's p of xy denotes the given functional equation. So we have that p of xy is this. So now I can start making substitutions, keeping in mind that we're talking of positive integers to positive integers. So we want to restrict all our substitutions to positive integers. So I suppose I say x is 1, I make x 1 and I leave y. So this is something like 2y into f of 1. 1 square is 1. Let me make it right. Plus 1 is equals to f of 1 plus 1. That is f of 2 into f of 2y. Let me call this equation 1. I don't know how this will help much. Just label. Okay. Now this time I make y1, x1. So I have 2 times 1 into f of x squared plus x is equal to f of x plus 1 times f of 2x times 1, and then I have 2 into f of x squared plus x equals f of x plus 1 f of 2x. I label this as 2. Okay, then let me make x and y equal now. Let me do them both 1 1. I will have that 2 times 1 into f of 1 squared plus 1 is equal to f of 1 plus 1 f of 2 times 1 times 1. And this means that 2 f of 1 plus 1 is equals to f of 2 times f of 2. This is times, please. Times f of 2, which is and that means 2 f of 1 plus 1 is equals to f of 2 all squared. Let me call this 3. Okay, so now I can come back to 1. You know that from 1 we have that 2y f of 1 plus 1 is equals to f of 2y. So, and I know that 2f of 1 is f of 2 squared. So I can substitute f of 2 squared for 2f of 1 plus 1 in 3. Okay, in 1 rather. I can do this. So when I do this, then I will have that y times f of 2 squared is equals to f of 2 times f of 2y. And then since f of 2 is not 0, y, f is from positive integers to positive integers. So f of 2 is not 0. That means y f of 2 has to be equal to f of 2y. I just basically divided by f of 2. This means, let me come back here so you can see why. This means that y f of 2 all square is f of 2y. And since f of 2 is not 0, I divide it through by f of 2. I have that y f of 2 is equals to f of 2y. Okay, so now we know that. How is this useful? Let me use another marker. So now we know that for all even integers, that is f of 2y equals y f of 2. So know what f is for all the even values of f. So let's come back to our original equation now. That was the problem statement. Let's come back here. The problem statement was 2y into f of x squared plus x is equals to f of x plus 1 into f of 2xy. This was the problem statement. So now I say let x be equals to 2t. T is some integer. T is a member of a set of positive integers. T is greater than or equals to 1. So then substituting this into this, let's call this equation star. Then that means we have that 2p of 2t and y. We know we call the problem statement p. This implies that 2y into f of 2t all squared plus 2t is equals to f of 2t plus 1 times f of 2 times 2t times y. I'm just substituting now. Then we can use the fact that this means that 2y into f of 4t squared plus 2t is equals to f of 2t plus 1 times f of 4ty. Okay, so at this point now I want to come back to our original value, to what we just derived. We know that we know what this is. We know all the even parts are actually doable. We can actually simplify all the even parts using this. Let me come back. Using this one we got before. Let me call this what do I call this? Should I call it star? Okay, let's do that. Double stars. Let me use that instead. Okay, so from star, okay, let me use black first. From the double stars we had, we know that f of 2y is y f of 2. So that means I can actually write, this is f of 4ty. This is f of 4ty is actually equals to f of 2 times 2ty. And since this is even, using this, I can write this as 2ty f of 2. So this is 2ty f of 2, this bracket here. Similarly, f of 4t squared, is equals to f of 2 times 2t squared. And I can, from stars, well, this is 2t squared f of 2. This is 2t squared, all this f of 2. So this equation, this entire boxed equation now So I can rewrite this entire box equation to reflect these changes. So I'm changing back to black now. So I'm still leaving it up there so you can see. So this becomes 2y f of, well, instead of having f of 4t squared, this becomes 2t squared f of 2 plus 2t equals f of 2t plus 1 times 2ty f of 2. Then I can cancel 2 out, y out. So I will have remaining then f of 2t squared f of 2 plus 2t is f of 2t plus 1 times t f of 2. But I can still simplify further, because if you look at this inner f bracket, if you look at this one, if you look at this bracket, it's still looking even. So this f of 2t squared f of 2 plus 2t, I can rewrite it as f, I can bring out 2 out. So this becomes t squared f of 2 plus t. And from our equation star, we know that this is the same thing as t squared f of 2 plus t times f of 2. Yeah. So I come back here. So I substitute this. So that means that, so this, okay, rather let me use this. Yeah. So this one is equals to this. The ones in green are equal. So that means I can do this now. So that means in place of all this, in place of this, I'll be writing this, the one in green. So that means that f of 2, I'm bringing out the common factor of t now. This will now be t f of 2 plus 1 is equals to f of 2t plus 1 times t f of 2. Once again, this cancels out. They are not zero. So that means f of 2t plus 1 equals t f of 2 plus 1. So at this point, as I usually like to say, we are almost done, because now we know that f of 2t plus 1 is t f of 2 plus 1. This is basically the same thing as saying that f of 2y plus 1 is y f of 2 plus 1, whatever y is. And we know that f of 2y is y f of 2. So what we've actually achieved now is basically that we've actually been able to find out what the function is in terms of, so when f is, so whatever number they give us, we can actually write it, if his number is even, so we can actually write it in, we know what it is. If it's an even number, we know the solution. If it's odd, we know what it is. So basically, but we don't know what f of 2 is, so we want to try and locate the value of f of 2. But keep in mind that all this actually holds, this is y is greater than or equals to 1 in both cases. So we know what from, so it's safe to say that from any input greater than or equals to 2, we actually know what it is. For example, that means we know that f of 3 is 1 times f of 2 plus 1. So we know f of 3 is f of 2 plus 1. We know f of 4 is 2f of 2. We know f of 5 is 2f of 2 plus 1, and so on. So we know what, we know f of 2 is f of 2. So what we know, so we know that for any x now, so we can say for any x greater than or equals to 2, f of x is either equals to x over 2 f of 2 if x is even, Let me write it somewhere here. For x greater than or equals to 2, we know that f of x is either equals to x over 2, f of 2, if x is even, or f of x is x minus 1 all over 2 if x is odd. So we know these two. So we have these two information now. So these are like the solution. But we don't know what f of 2 is. F of 2 is a constant. We need to find out what f of 2 is. So how do we do that? We'll come back to our initial equation now. Then we'll try substituting in let's write out our initial equation again. That was 2y f of x squared. We still need to know what f of 2 is f of x plus 1 and f of 2xy. Okay, so with this, why don't we pick some values and set it in? Supposing we said let's set x equals to 9, and we know that 2y into we're trying to locate f of 2 now, into f of 9 squared plus 9 is equals to f of 10 into f of 2 times 9 times y. This is, and that means 2y into f of 81 plus 9 is equals to f of 10 times f of 18y. And this f of 18y is the same thing as 9y f of 2. We already knew this before. So then I will rewrite this. And then I have that 2y into f of 81 plus 9 is equals to f of 10 times 9y f of 2. Y cancels out. So I have something like 2 into f of 81 plus 9 equals f of 10. Okay, let me say 9 f of 10 f of 2. All right, so far so good. Then we know that f of 81 is we said this is 81. Since this is odd, this is 81 minus 2 into f of 2 plus 1. So f of 81 is 40 f of 2 plus 1. In case you can't see why I say it here, I'm going to use pink. Let me use blue. Since f of 2y plus 1 is y f of 2 plus 1. So this is why f of 81 is 40 f of 2 plus 1. So I come in here. So this means that this is equal to this. So that means I can rewrite this as 2 into, let me go back to my initial sheet, sorry. 2f of, in place of f of 81, now I put this 40 f of 2 plus 1 plus this 9 is equals to, and f of 10 is f of 2 times 5, and this is 5 f of 2 times this f of 2 here. So this is implying that 2f of 40 f of 2 plus 10 is equals to 45 f of 2 all squared, f of 2 squared. Then to come back to this inner f here, sorry, let me write it closer so you can see this f, so the f doesn't look too far away. We'll come back to this inner f. You know that f of 40 f of 2 plus 10 is equals to f into 2, 20 f of 2 plus 5. And since this is even, this is the same thing as, so this actually becomes our y now. You know, we said that we had f of 2 and then equals y f of 2. So this becomes our y. So this is 20 f of 2 plus 5 times f of 2. So that means so that means all this is equals to this. Let me direct you there so you can see it. So I can rewrite that as, so this means that 2 into 20 f of 2 plus 5 times f of 2 is equals 45 f of 2 squared. And since f of 2 is not 0, that means 2 into 20 f of 2 plus 5 is equals to 45 f of 2. I expand, 40 f of 2 plus 10 is equals to 45 f of 2. And then collecting like terms means 10 is equals to 45 f of 2 minus 40 f of 2. And that means 10 is equals to 5 f of 2. And then only f of 2 will be 10 over 5, which is equals 2. So f of 2 is 2. So what does this mean? It means that f of 2y plus 1 is, which is equals to y f of 2 plus 1 is equals to 2y plus 1, since f of 2 is 2. And that means f of 2y, which is y f of 2, is equals to 2y. So in summary, I can say that f of x is equals to, this means that f of x equals to x for all x greater than or equals to 2. Now, if you notice the problem, there's something we've not yet considered. We're almost done now, like 99% completed. I would say 99, but we've only found the solutions for x. We know that f of x equals x for x greater than or equals to 2, right? But what about x equals to 1? We need to also consider this question. How do we find x equals to 1? Well, it's still a similar thing. So you just come back to our initial equation. We set x equals to, let's say x equals to, okay, we know that we don't even need to, we know that initially, let's go up so we can see something. I'm going up to the first line now. We know that we had that, okay, see this. I'm going to use here blue for this. We know this is true. We had this at the beginning of the problem, right? So let me bring this down so we can work with this. You can now say that from 3, we know that 2 f of 1 plus 1 is f of 2 all squared. And f of 2 is 4. F of 2 is 2, so this is equals to 2 squared. So that means 2 f of 1 plus 1 is equals to 2 squared. This is 4. So that means 2 f of 1 plus 1 is equals to 4. And that means f of 1 plus 1 is 4 divided by 2, that is 2. Since f is from the set of positive integers to positive integers, okay, let me use this, okay, n to n. Then we know that f of 1 has to be greater than or equals to 1. So f of 1 plus 1 is greater than or equals to 2. So this can actually work with our f of x equals x for x greater than or equals to 2. So we know that all this, since this is greater than or equals to 2, we know that f of is equals to f of 1 plus 1, since f of 1 plus 1 has to be greater than or equals to 2. Therefore, this is f of 1. That means we have f of 1 plus 1 equals 2. And that means f of 1 is 2 minus 1, which is equals 1. F of 1, it's 1. So we know that f of 1 is also 1. So we see that f of x is equals to x for all cases. So, and we're done for all x. So this is the only solution. So the only function that works is f of x equals to x, and that's all. So with that, we've come to the end of this problem solving session. If you like this video, you can check out more videos on our channels, and we'll have more problem solving sessions in the following weeks. You can also register for our summer camp if you want your kids to do this. If you're a parent or you're a kid watching this, you can register for our summer camp. It's coming up from August 1st to August 29th. You can register for it if you want to do something like this. We'll be laying the foundations of Olympiad maths. We'll be talking about functional equations and other cool stuff there. You can also interact with us on social media to find out more about our latest programs and all. In the meantime, bye for now. My name is Ogene Obukomejaifi, and I hope to see you soon in that problem solving session.